For today's question, we are going to discuss this question from SMO 2012 Junior section. You are asked to find the minimum value for this expression, that is square root of x squared plus 20 minus 1 square plus square root of y squared plus 21 minus z squared plus square root of z squared plus 20 minus w squared plus square root of w squared plus 21 minus x squared. You may note that 20, 21 appear several times. Have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
I'll solve this question using two different methods. Both are quite related. Number one is using idea of vectors, and number two is using geometric coordinates. For the first method, I'll consider vector OA, that is x 20 minus y. And next, AB, the vector AB is 20 minus z, y. Vector BC is equals to z 20 minus w. And the vector CD equals to 21 minus x and w. So let's say this expression is equals to j. Then we'll see that j is just equals to the length of OA plus the length of AB plus the length of BC and plus the length of CD. And using triangle inequality, we know that this will be greater than or equal to the length of OD. We can imagine that this is O, this is A, this is B, this is C, and this is D. O to A to B, B to C, C to D. It must be at least the length of BC, because from here we know that this portion is smaller than the sum of these two using triangle inequality. Similarly, the sum of these two lengths is greater than this portion, and therefore the minimum must be at least OD. Then from here we know that OD is actually equals to OA plus AB plus BC and plus CD. So when we add up together, the corresponding component, that is x 21 minus z, z 21 minus x, and you can see that x will be cancelled off, z will be cancelled off, and we have 2 of 21. Likewise, for the second component, y will be cancelled off, w will be cancelled off, and we left with 2 of 20. So this is double of 21, 20. And with this, OD must be equal to 2 times square root 21 squared plus 20 squared. This is a well-known Pythagoras triple, 20, 21, and 29. So 2 of 29, that is 58. So this is equal to 58. Now, so it means that J is greater than or equal to 58. For those who follow my video, you know that I always like to consider whether the equality holds. So we know that the equality holds if and only if, in this case, OA has to be parallel to AB and parallel to BC and parallel to CD. And this means that OA is equal to K1AB equals to K2BC equals to K3CD. And we need to ask whether it is possible. There are quite many different values of x, y, z, w satisfy this condition. And we can choose x equals to z equals to 10.5 and y equals to w equals to 10. When we sub in all this and we do the calculation here, we know that j will be exactly equal to 58. And therefore we found out that 58 is a minimum value of j. So 58 is our answer here. So this concludes the first method. I'm going to do the second method now. If you enjoyed this video, please like, comment, and subscribe. For second method, I'll consider a few points on the xy coordinates. First of all, I consider origin that is 0, 0, then followed by x 20 minus y. And B, I'll consider 21 minus z plus x and 20. Next, C, I'll consider 20 plus x and 40 minus w. Last but not least, D, I'll consider 42 and 40. We can see from here that out of these 5 points, the point O and the point D are two fixed points. O and D, this is somewhere here. These are two fixed points. Whereas A will determine by the value of x and y, and B will determine by z and x, and C will determine by the rest. For the point B, the coordinate y is fixed, that is 20. So it's half of here. So it must be somewhere here. So let's say this is A, x 20 minus y. And for B, let's say this point here, this is B, 21 minus z plus x, and this is 20. So for C, let's say it's here, 20 plus x and 40 minus w. Okay, so after we've all this, we try to understand what is the relation between these 5 points and the J. So for J, the first term is square root of x squared plus 20 minus y squared. And this is actually meaning the length of OA. So J is equals to the length of OA. From the definition of A and B, then we see that the second term is actually the length of AB. So this is AB. And likewise, BC is equivalent to the third term. The length of BC equivalent to the third term. So this is BC. And lastly, CD is the length of the fourth term. And similarly, J must be greater than or equal to OD because of triangle inequality. And what is OD? OD, that is obvious. It is equals to the square root of 42 squared plus 40 squared. And that is 2 of 21 squared and 20 squared. And we already know that this is 29, so this is 58. There are many different values of x, y, z, and w such that the equality holds. If we choose x equals to z equals to 10.5, y equals to w equals to 10, and we can see that the equality holds. Again, using this method, we confirm that 58 is a minimum value of J, and therefore 58 is the answer for this question. That's all for today's lesson. I'll see you again next time. Bye-bye.